Hey guys, in this one we are looking at our third and final form of the equation of a straight line. Now it's this guy, ax plus by plus c is equal to 0. So this form might look a bit mental for a start, because you've got x and y on the same side. I, having gone through a maths degree and all of that, still find equations that look like this a bit strange. A, B and C are all integers, so when we write equations in this form we don't have any fractions at all, so it does make it look a bit nicer in that respect. So there are a couple of things to be aware of when writing equations in this form. The coefficient of x is not the gradient here. In the other two forms, y equals mx plus c or y minus y1 is m times x minus x1. M is the gradient, it's the coefficient of the x term. In this form, it's not. To be able to get the gradient, we need to have y on its own on one side and x and whatever else on the other side. So in this form, the coefficient of x is not the gradient, and also c is not the y-intercept. So to get those two things, we have to take an equation that is already written in this form and rearrange it into y equals mx plus c, which is the first type of question that we are going to go through. Then we're going to have a look at how to write equations in this form. So because the gradient is not involved in this form of a straight line, they're quite hard to actually get to directly. So what we're going to do is write the equation of the line in one of the other two forms and then rearrange it into this form. So questions will often ask you to do this when you get fractional gradients or fractional y-intercepts. In some ways it looks quite a bit neater, in some ways, to me, as I said, it still looks a bit mental. But we've got to do what they ask us to do, so let's get cracking with some examples. Okay, first up then we want to find the gradient and y-intercept of 5x plus 9y minus 2 is equal to 0. So it's not too tricky, we just need to make y the subject of this equation. So I'm going to start by adding the 2. So that's going to give us 5x plus 9y is equal to 2. Then I'm going to subtract 5x. So we get 9y is 2 minus 5x. And then finally, we just divide through by that 9. So we get y is 2/9 minus 5x over 9. Now you could, if you prefer, write that as y is minus 5x over 9 plus 2/9. Either one of those is fine. The important thing is that we can now say the gradient is minus 5/9 and the y-intercept c is 2/9. Okay, so all we've done there is make y the subject, so we're turning it into y equals mx plus c, and there we go, we've got it. Okay, example 2, we want to write y equals 2/3 x minus 6 in the form ax plus by plus c is equal to 0. So we're doing what we just did but in reverse. So we've got y equals 2/3 x minus 6. So I'm going to get rid of the fraction. First of all, I'm going to multiply both sides by 3. So we're going to get 3y 3y equals 2x minus 18, like that. So let's go rid of the fraction. Everything is now integer. Good times. If we add the 18, 3y add 18 is 2x. Not sure where that minus came from. So 3y add 18 is 2x. And then finally subtract 2x minus 2x. Add 3y add 18 is equal to 0. There we go. Okay, example 3. A line has gradient minus 5/3 and y-intercept 2/7. Write this line in the form ax plus by plus c is equal to 0. Good times. Okay, so first of all, we want to use the information that we've got to write the line as y equals mx plus c. So we know the gradient is minus 5/3. So we've got y is minus 5/3 x, and then the y-intercept is 2/7. So plus 2/7. So it's easy to see with an equation like this why we might want to write it in another form. It looks horrible. So first of all, let's get rid of the fractions. So first of all, I'm going to multiply everything through by 3. So that's going to give us 3y equals minus 5x plus 6/7. Okay, that's sorted out the fraction and gradient. Now I'm going to multiply through by 7 to sort out the fractional y-intercept. So we're going to get 21y is equal to minus 35x plus 6. Now it's just a case of moving the two terms on the right over to the left. So if we add 35x, 35x plus 21y, and then if we subtract 6 minus 6 is equal to 0. So there's our line in that form. Good times. Okay, final example then. So final equation of the line passing through 7, 3 and 1 minus 2 in the form ax plus by plus c is equal to 0. So first of all, we need to find the gradient and the y-intercept. So let's say let's first of all get the pen out. x1 is 7, y1 is 3, x2 is 1, y2 is minus 2. So the gradient is gonna be y2 minus y1, so minus 2 minus 3 over x2 minus x1, 1 minus 7. So that's going to give us minus 5 over minus 6, which is positive 5, 6. So if we use, actually here I'm going to use y minus y1 is m times x minus x1. So the reason that I'm using that is that we then don't need to faff around finding the y-intercept. So, we can now say that y minus 3, let's go for, so y minus y1, y minus 3 is 5, 6 times x minus x1, so x minus 7. Okay, so there's our equation. We just need to rearrange it. So the first thing I'm going to do is multiply through by 6, which is going to sort out this fraction. So we're going to get 6y minus 18 is, now I'm also going to expand the brackets. 5 times x is 5x. And then 5 times minus 7 gives us minus 35. So, again, there's our equation. We just need to rearrange it. So, if we subtract minus 5x plus 6y minus 18 is equal to minus 35, and then just add 35. So we get minus 5x plus 6y plus 17 is equal to 0. There's our equation. Remember, you can always check it by substituting in one of the pairs of coordinates, making sure it works. Okay guys, that's it for this video. If you want any more or have any questions, let me know down below in the comments.